This video is about doing the weight and balance for a Cessna 172, and the center of gravity of the Cessna 172 determines the balance of the airplane. And you want the center of gravity, here's the symbol right there, the center of gravity to be between about 43 and 47 inches aft of your datum. Well, your datum is your reference point. That's the 0 point that you measure in inches, the moment. Now, moment, again, is the distance. It's a rotational force, and it's the distance from, in this case, the datum, and you multiply it by the weight. So moment equals the distance in inches times the weight in pounds. So the units are going to be inch pounds or pound inches. You can use those interchangeably. Inch pounds or pound inches. So for the Cessna 172, the 0 of the datum is right here at the firewall. Other airplanes can be a little bit different. For example, the Cirrus R22, its actual datum or 0 point is 30 inches in front of the nose, and it's totally determined by the OEM or the manufacturer. For us, we want to determine the center of gravity for the Cessna 172 and make sure it's within limits. If it's within limits, it will be in front of, this is the lift vector, which happens, the lift of the airplane happens in the center of the wing, or pretty close to the center of the wing. And so if the CG is forward, if you will, and in limits from about 43 to 47 inches after the datum, then you're going to have a nice nose down rotational moment based on the lift vector, which is going to keep the nose down and keep the airplane stable. The problem is if this CG comes back here aft of the lift vector, then you're going to introduce actually a nose up or rotational moment around the firewall, and you're going to fly nose up. And if you fly too far nose up, the elevators won't be able to correct it, and you'll stall the airplane. You won't be able to fly, and it becomes unstable. So you want the CG to be at or forward of the lift vector, and for the Cessna 172, it's between about 43 and 47 inches after the datum. But we are going to calculate exactly how to do our weight and balance. Now, this diagram shows that each position in the aircraft with weight generates that moment around your 0 or datum, which is up here. There's your datum point up here at the firewall. If you're in the pilot or passenger seat in the front seats, and depending on where you slide the seats, they can slide anywhere from 34 to 46 inches from that datum line. Now, how do I know the moment? Well, let's say I put a 200-pound, let's keep the math easy, a 200-pound pilot in here, and we're going to say he's got a seat in the middle, so it's about 40 inches. So my moment that I'm going to create by a 200-pounder 40 inches from the datum is basically you multiply the two. So the moment equals the 200 pounds times your 40 inches, which ends up being 8,000 inch-pounds. Now, for our charts, what they do is they take that 8,000 inch-pounds and they divide it by 1,000 so that you could go into the graph, and that's arbitrary. But basically, you've got 8,000 inch-pounds that you're generating with a 200-pound pilot. And, of course, on your chart, it's going to show up as 8 because they've divided it by 1,000. Now, as you go aft from the datum, your rear passengers have a distance of about 73 inches from the datum. So what you would do, you take your rear passenger weight times your 73, and that is going to give you the moment for the weight that's in that rear passenger seat. And again, the further aft you go, the more moments you generate, because baggage area 1's an average of 95 inches and baggage area 2 is an average of 123 inches. So you take the weight in there and you end up multiplying the weight times the distance. and that gives you the moment. Now, how do I find the CG in a table method? Well, what I'm going to do, I'm going to take the sum of all the moments, and I'm just going to add them up, and then I'm going to take the sum of all the weights, and I'm going to add them up, and that will give me the CG. That will give me the position of that center of gravity, and we'll do that in just a moment. Now, this table is a sample weight and balance that came out of the POH for a 172, and I'm going to explain how it works. And again, this is our weights at each station that we saw at the last slide, and these are the moments. And again, the 1642 and 62.6, which would be 62,600 inch-pounds, is the basic weight, which comes from the manufacturer's weight and balance. The next one down, of course, that's 1642 and 62,600 inch-pounds. Now it's 62.6 because they took it up here and they divided it by 1,000 to help us enter the graph. 30 pounds of fuel, and the wing fuel stations are at about 47 inches. So you take that 180, multiply it by 47 inches, and 30 gallons at 6 pounds per gallon for avgas gives us 180 pounds. Times the 47 inches, about 8,600. And so divided by 1,000 is your 8.6, so we can enter into the graph. Here's your 340 pounds, if that's, for example, 2 people in the front 2 seats, multiplied by an average of 37 inches, and then that gave us that 12,600 inch-pounds, or the 12.6 when I divided by 1,000. Back seat passengers or rear seat passengers, we're going to say there's 340 pounds for 2 people, and multiply that by the moment distance, and that would give us 24,800 inch-pounds, which divided by 1,000 is 24.8. Passenger area 1 had a distance of about 95 inches, and so that's at 56 pounds times the 95 inches gives us that 4,600. On down, and here is how you find the total position of the center of gravity. Here's the total weight, just add them up in the column. Here's the total moment, add them up in that column, and you can see it's 2558 and then 113,200. Okay, and we divided it by 1,000 so we could deal with the graph. This is your taxi fuel, and you lose a little bit. Remember, it was 47 inches from the datum. And then subtract that out, and your total takeoff weight was 2550, and the moment was 112,800. Now, how do I find the CG? Well, right up here, I took the sum of all the moments here, put it on the top, divide it by the 2550, right there. And if you can't remember, you know it's going to be inch-pounds over pounds. So what's going to cancel out is your pounds. It's my mathematics stuff there, and you end up with inches. In this case, we calculate 44.2 inches as the CG. Now, we're going to check the graph and the chart of that to make sure that we are in limits with that 44.2, and let's do that. As an aside, this is one of the graphs you're going to find in your POH, and if you don't have a calculator, this thing works really, really well. And if you recall, we had 340 pounds in the front seats at 37 inches. So you can find the moment. So you just enter the chart here at about 340 pounds till you hit the line. And this is the average at 37. Read straight down right there. And basically, there's your, looks like about 112, just like we talked about. All right. So, or 102, 103, right in that area for your moment. So that's your moment divided by 1,000. For your fuel, say you had 300, or there was 180 right there. There's your 180 pounds. Read straight down. And then there's your moment right there, which we said was 8.6, which that looks pretty good. So this graph is really good. If you don't have a calculator, you can just enter the graph and find out the moments based on your weights. And this line here gives you your position. So there's your rear passengers. Say, we'll just say we had 300 pounds in there. We had 340 in the example problem, but read straight down, and again, that would give you your moment, which is, again, divided by 1,000, which looks like about 21. All right, so and that's pound inches, so 21,000. So this graph is really good if you don't have a calculator. Then you can figure out your weights in moments. In determining your weight and balance, these are two of the graphs that you're going to see in your pilot operating handbook. The first one on the right will help you find the CG, just like we did. You can divide it out like we did, and we said it was the sum of the moments divided by the sum of the weights. Okay, in our case, when we did that, it ended up being 44.2 inches for our example problem. But you can also enter this particular graph. We said it was about 112,000, and you entered with 2050. So I went in here at 2050, and right about there is 112,000. Boom. You are right here. Now this graph tells you that you're within the box for CG limits, barely, but you're there. And if you read straight down here, you'll get the 44. A little bit hard to see, but you read straight down and you get the 44. Now there's two types of center of gravity categories. There's a normal category, which you can do any types of maneuvers, and then you have the utility category where it's expanded on what other types of maneuvers you can do. So for this chart, again, you enter with your weight, and then you have the CG at the top, and then it tells you you're in weight and balance if you're in that box there. And then you can actually read the CG at the bottom. So that chart is really good. That's found in your POH. This next chart basically just gives you, we'll move it right here where you can see it a little bit better, basically tells you whether you're in weight and balance limitations again. So there we go. So we enter again the chart at 1250 and come straight across, which was right about in that area there. Okay, and then we said that the CG was about 112 inches, which is right about there, and you read just about straight up, pardon my good straight line. And you can see at that heavy weight, we're still in the normal category. So you can check both of those graphs and know that you're in your weight and balance limits, and in this case, the normal category. So on the quiz that I'm going to give you, I'm going to give you a weight, and I'm going to give you a distance, and you're going to have to find the CG. Okay, and you can do that in the table method, just like we showed here on the video.